Okay, well, good evening, graduate UNSY students. So once again, for everyone's awareness, we are recording this session, and a copy is going to be made available for those who are unable to attend live. Next, the format of tonight's meeting, I'm going to start by introducing our guest, who will then describe his connection to the unmanned system technology field. Afterwards, I'm going to lead a series of introductory questions, after which we're then going to open up to a class-wide Q&A session. I do ask that you mute your mics and save all your questions to the end, and that you use the hand raise icon to indicate when you do have a question. I'll call on each of you in order, and I do also want to note that I will be trying to capture and share online links to important concepts, details, and tools that might be brought up in tonight's discussion. So you might see me grabbing my iPad, and I'm not surfing social media. I am usually grabbing the material real time as it comes up in our discussion organically, so that tomorrow or Friday or over the weekend, if you want to just dive into that topic or subtopic a little more, you'll have it right there. So with that, I am really just thrilled to welcome you to the 18th session of the UNSY Guest Subject Matter Expert Speaker Series. This is the third and final for this term. I am Dr. Brent Terwilliger, the program coordinator of the Master of Science in Unmanned Systems degree. Tonight, we are joined by our guest subject matter expert, Christian Ramsey, the president of UAvionix. UAvionix is an advanced technology company that develops certified and uncertified communications, navigation, and surveillance avionics for UAS. They also support the general aviation and defense markets. Christian is currently a member of the FAA's Advanced Air Mobility Advisory Committee and was formerly a program manager for Harris Corporation on the FAA's Surveillance and Broadcast Systems, ADSB program. As well, he was a program manager for UAS R&D programs. He has spent his entire career in aviation technologies ranging from aircraft and flight simulation, aircraft surveillance system, cloud-based surveillance services, and avionics. He's a private pilot and licensed UAS pilot under FAA Part 107. And I want to mention that I met Christian back in mid-2000s when we were both at Rockwell Collins Simulation and Training Solutions up in Binghamton, New York. That's kind of where I got my start in aviation and aerospace. Over the years, we've repeatedly found ourselves in the same circles, which really isn't much of a surprise if you consider the relationship that exists between Collins and advanced aviation technology. What's just kind of interesting is that we both kind of coalesced around UAS. As with our last session, our guest from session 17, Christian and I both sit on the NBAA Emerging Technology Committee, where we look at pressing challenges and opportunities that are affecting our shared aviation space and infrastructure. And with that, I would like to turn the stage over to Christian just to tell us a little bit about UAvionix, as well as his experience and observations associated with this rapidly changing technology.
Thanks, Brent. Appreciate that. Yep, we go back a ways. That's good. So you, just a couple quick questions here. So we're recording. Is this going to be posted anywhere, or is this just an internal distribution?
Internal. Okay. Yeah, I'll share it internally.
Yeah. And it seems like your students here are, I think, as we discussed, sort of pretty well engaged in the industry and understanding of aviation and generalities. So if I speak some acronyms or something that don't make sense, please stop me and get me to explain this. So I appreciate that.
That's where my note taking is going to come in for tomorrow. So yeah, as we go into any discussions of acronym alphabet soup, yeah, we'll get them up to speed in the next couple days.
Good. Well, look, as we discussed the other day, I hope this is going to have to be more of a conversation than a presentation, right? So I'm happy to give sort of an introduction of myself, and that you did some of that there, and UAvionix and what we do and where we're headed. But really, am eager to sort of hear your questions and engage in some good dialogue. So hopefully you guys can help me out there. So you might also hear me rambling if we don't do that, because I'll just keep talking and it might not be where we want to go. But
You're good. We'll keep it on track.
Yeah. Well, hey, I'm currently in Leesburg, Virginia. UAvionix has a small office here, centered around our business management, business development, marketing, sales, regulatory interface office here. I've always been here in Virginia. Our manufacturing facility and our technical true headquarters is out in Montana, in Bigfort, Montana. And the reason we're there is because our founder is a gentleman named Paul Beard, who had several technical and business successes and retired out to Montana and kept unretiring and kept coming out there. So I'm not sure if anyone here is a remote control aircraft enthusiast, but Paul was the founder of a brand now that's called Spectrum RC. So it's effectively the command and control radio for RC radios. And so he was the inventor of that technology, which solved a really core problem back in the day, which was, there was no frequency pairing or digital spread spectrum usage of RC aircraft or ground vehicles as well. And there was a real manual coordination that needed to occur on these flying fields so that you wouldn't accidentally take over and crash your friend's aircraft. And Paul solved that problem with the implementation of digital spread spectrum. And then he became a helicopter pilot, and that's about the time frame that I met Paul. So after I left Rockwell Collins, where I knew Brent, I moved into what was a series of a single company with a lot of names. It began as ITT, and then it was Excellus, and then it was Harris, and then I guess that's where I left it. But now, of course, everyone knows it as L3 Harris. But while I was at Harris, I was involved in a number of different projects, and from airport surveillance projects to national surveillance projects with the ADS-B network. But the most fun I had was running research and development programs, really leveraging at the time the surveillance system that we had put in place for the ADS-B network for detect and avoid. And we needed some really small avionics for our tests so that we could fly these systems. In particular, we needed ADS-B systems, and that's where I met Paul. And eventually decided to jump ship from Harris and try my hand at a startup. And it's been 6 years this month. So it's been a fun time. We are primarily an avionics manufacturer, as Brent discussed, and we started off focusing on drone avionics and ADS-B specifically, and that sort of quickly spread to other components of a system. Initially, GPS was really critical, because if you're flying with an ADS-B system, you have to have a compliant GPS that meets certain qualifications from the FAA's perspective. Otherwise, anybody that receives ADS-B will just ignore you, frankly, right? And the reason we thought ADS-B was going to be such a critical technology, just to sort of back up and explain that technology, is it's kind of the original remote identification idea, where the idea of an aircraft reporting its own identification and position using air equipment on board the aircraft, as opposed to a ground-based radar with a lot of spinning energy with an antenna bouncing off the aircraft and then trying to determine where that aircraft is. Those large radars have quite a bit of error in them, and the idea was ADS-B in the manned world was going to help get more precision out of aircraft locations, and you'll get more aircraft in the sky, and that's why ADS-B was developed. Now, of course, when you think about drones, that seems like a great opportunity. If you know where all of the aircraft in the sky are, then you can avoid them. If you're a participating aircraft and ADS-B out, meaning you're transmitting, you're telling everyone else where you are. And so that was the impetus for the initial investment in UAvionix. And of course, we've expanded further to include general aviation products and airport-based products, and even some defense products now. So there are all sort of generally in that what we call the communications, navigation, surveillance, or the CNS space. So you know, we've got a broad range of products. Too many, our support team would say, and our manufacturing team would say. But you know, the market has been quite diverse over the past few years. Some of the things we're heading towards in the future is we've shifted a lot of our internal focus to command and control networks now. So not just the avionics on board the aircraft, but the system on the ground that can be used to string together a number of towers over a region or a linear infrastructure and be able to hand off from one tower to the next to infinity if you can, right? To achieve those beyond visual line of sight missions. And we've you know, been implementing several of those projects. The most notable is in North Dakota right now with the Vantas network. We're the command and control network provider for that system. We're also being deployed at the Choctaw Nation Beyond program there in Oklahoma. And I cannot say who just yet, but I think we'll soon be in Florida. So we're really excited to be able to expand our networks. So we're really excited about that capability. We think that's you know, a really important differentiator, you know, bringing certified avionics to a network solution that's, you know, ultimately, you know, quote, certifiable or waiverable. That allows our customers to do that. Might be a good place to pause, Brent, if you want to feed me softballs.
A couple follow-ups, and
okay.
As you were talking, I was trying to go out and grab snippets of materials to help the class conceptualize a lot of what you're talking about. So one of the things that has come up, and you got into a little bit about ADS-B and kind of how that works. There's been a lot of pushback on using the technology on UAS, especially SUAS. And the biggest argument that comes out of the opponents of it are that it's going to overwhelm or overload the system. You're, as a user, if I'm flying a jet, a biz jet, or if I'm flying a general aviation aircraft, and I'm over dense operational areas, especially say here in Florida, it will be difficult to filter out all those potential signals if we were to put them on all the UAS out there. But you guys created a new way of kind of looking at that, and some new technology a couple of years ago with ADS-B, including micro miniaturization.
Yeah.
Where do you guys stand with that? And do you envision it also translating over to the eVTOL space?
Yeah, it's what's one of the most interesting and most frustrating things about that particular topic is that almost every country in the world has a little bit different idea of how they want to use ADS-B when it comes to drones, or if they don't want to use ADS-B when it comes to drones. Of course, in particular for us, the biggest and closest market was the US, right? And so we thought, you know, it'd be a fantastic opportunity to equip drones. You know, 5 years ago, this conversation was happening. It'd be a fantastic opportunity. And coming from being a program manager on that program, I understood the technical underpinning of the concerns that I knew we were to hear regarding overwhelming of the signals, unable to filter data, and so we came up with a couple of options that we thought would make some traction. ultimately didn't. First is low power. So when you design the ADS-B network and your primary purpose of ADS-B is surveillance and air traffic control, you don't want to put a really dense network on the ground because that's really expensive. What that translates to is less dense of a network on the ground and higher power transmitters in the air so they can reach longer distances. But that's not really what we want to use ADS-B for drones. We don't want to air traffic control these things. We just don't want to run into each other. So when you're thinking about not wanting to run into each other, you don't need to factor in the ground network. You really just need to factor in your air-to-air capability of ADS-B so that you can receive that signal. And when you take that air traffic control function out of the idea of ADS-B, you can do some really cool things like miniaturize it down to a chipset with really low power. And we demonstrated and tested systems that were 0.1 watt of transmit power. And just to put that in perspective, the transponder we build is 250 watts, right? So that 250 watt transponder is going to go, 400 miles of signal range. The 0.1 watt was about 1.5 miles, right? And so, we thought, wow, this would be a great idea. Let's put really low power systems on board. It didn't make the cut. So the next thing we proposed was a system that we called inert and alert. And the idea of inert and alert is you've got a system that doesn't transmit at all unless it has to. So it's detecting the other aircraft around you. And it's sort of the analogy is like blowing your car horn, right? Someone's encroaching into your lane, you blow the car horn and let them know you're there. And that was the idea sort of behind inert and alert, is that they don't know you're there until they have to know you're there, and then you can do that. So, neither one of those really got much traction. And as you guys probably know, in the remote ID Part 89, rules, they, put some pretty strict limitations on the use of ADS-B for UAS. You have to be operating under air traffic control services in controlled airspace with a filed flight plan, et cetera. So that kind of limits you to higher altitude, larger, there's nothing in the rule that dictates size, but the aircraft they're going to be flying in those situations are probably the larger aircraft, flying in those scenarios. But what's kind of also interesting is the rest of the world's take on ADS-B. So the US was very protective of that network that we built because it cost us a couple $2 billion to build and deploy. And no other country in the world has spent that much money to deploy a system that needs to be so well protected. And so it's almost like an opportunity for a leapfrog technology like mobile phones. You don't have to install landlines. You can go straight to mobile phones in some parts of the country, right? It's almost like you can leverage it in ways that weren't initially envisioned. And a good example is the UK. Here in the US, we use 2 different frequencies for ADS-B, 1090 megahertz and 978 megahertz. The rest of the world only uses that 1090 megahertz frequency. No one else is using 978 megahertz, or what's called UAT. UK and now some other countries are starting to pick up on the ideas that, well, hey, why don't we use that 978 frequency for drones and 1090 for manned aircraft? And that's a direction that looks like the UK is going. And sort of even on the opposite extreme country, India, for example, mandates the use of ADS-B on their drones if you're flying in certain airspaces. So you go all the way from one country like the US where it's banned to another country where it's mandated, and then somewhere in between, countries trying to find, solutions that make sense.
Outstanding. What can you tell us about some of the advanced technologies you guys are looking at? Are you exploring the integration of AI or machine sensing into what you're doing regarding comms and avionics?
Yeah, and that kind of falls into that category of the command and control networks. So there's a lot of investment internally on that particular component. So I'll give you a sort of a storyline example of how this might work. If you've got a ground radio, we internally call them GRSs, ground radio system, right? The ground radio on the ground and an airborne radio in the air, or the ARS. You've got a point-to-point system, right? You've got one tower, one aircraft, and in the case of what some of you guys might fly, the quote tower is the handheld controller that you're flying, right? But you've got a transmitter on the ground, transmitter in the air. We spend a lot of money in developing and being able to certify what those radios are. So you've got a sort of a level of qualification that goes along that. But radios have different advantages and disadvantages depending on the frequency they're used, the power output, the altitude or the geography that they're operating in. So in order to expand that point-to-point network, you want to put multiple towers along the ground. Multiple towers along the ground require, from an FAA safety case perspective, that you're never in even a minuscule nanosecond of a lost link scenario. So as you're transitioning from tower A to tower B, you have to reach forward and establish a solid link with the upcoming tower, tower B, before you can let go of tower A. And that's called a make before break, right? You want to make that connection before you break the old connection. And so you have to have effectively two radios in one, which is, the architecture of our design, so that we can reach out and make that new connection before we break it. And so that was iteration one of our development. How do we do a make before break scenario in terms of being able to transition from one ground radio to the next ground radio to the next ground radio? And then we started, adding even more complexity to the overall solution. So there's something called, you want to mitigate the potential for a lost link scenario, and there are several ways to do that. One is, in the engineering world, we call path diversity. So is there more than one path for the data to get from your aircraft to the ground, right? Well, obviously, when you've got two towers on the ground, that's more than one path, right? If you've got two radios on the aircraft, that's more than one path. But now you multiply that by a network of towers that are all monitoring your system. And now you've got this great advantage of path diversity with two radios in the air talking to multiple radios on the ground. And that's even very interesting. But
that's a multiplexer, correct?
That's a multiplex, right? And now we're even going even further by two steps. So now we've got this system on board the aircraft that can allow the two different types of radios. So we might have a radio that's operating at 900 megahertz and another radio that's operating at 5 gigahertz. And now this system on board can help determine the best one of those options to use. So what we've created is this, we call it a skyline system. And it is a C2 network manager that is monitoring every single one of those multiplexed connections and choosing through intelligence what the best selection is from the ground and the air at any given moment, or presenting that information to the operator to make that choice themselves. So you can see a list of signal qualities. I want to connect Tower A with my C-band radio, or Tower B with my ISM radio, or this is a great place for an LTE radio to be used, right? Just depending on where we go. And a great example of that is, the sort of the envision, if you're taking off in a location that is, fairly urban, you've got great cellular connectivity. You can take off with cellular connectivity, but maybe with an advanced air mobility vehicle, it's going to exceed the altitude limitation of good connectivity with a cellular network. And you're going to need to transition to something like a C-band or 5 gigahertz radio. for its long haul distance. And then as it's coming back into land, it'll, change frequencies once again. So there's a lot of complexity going into sort of how we're managing that overall network.
Excellent. So now I'm going to toss you a couple just higher order questions, and then we'll prep to switch over to the class and allow them a chance to put you on the grill. What are the tools or resources that you personally use to stay informed? And what are some of the challenges you find of sifting through the volume of available data?
Well, it's probably not too different than most of what you guys do, right? I mean, so I try to select and sample, I guess first sample and then select the sort of groups that I'm personally a member of, or we as UAvionix are members of, right? And so that we can sort of monitor, monitor the industry from the perspective that we feel we play. So, for example, we're contributing members to RTCA, which develops standards for the radios that we develop. So we can help shape the direction that the standards are going, or just react to them in a way that helps us come to market in a particular way. Other groups, you mentioned that I'm part of the DAC/AC, right? That's something that keeps me informed on what's going on. The ETC you mentioned, we're members of the Commercial Drone Alliance, CDA, right? And sort of they're great for sort of keeping tabs on the legislative environment. There are so many drone groups out there that you really can't spend all of your time in all of them. So over time, we've sort of settled on some of those things. My inbox is full of daily, weekly news feeds, and and I've got a stack of magazines right over here, right? And I just try to peruse headlines to keep tabs on things until something sort of hits. There's a lot of, as sort of noise, right? There's a lot of people shouting about how great whatever is, or we did something, or and it's there's a lot out there in terms of a lot to be confused by, I guess would be a good way to say it.
Great. What are some of the pressing technological problems that you see on the forefront of things? What really needs a lot of attention placed on it? Because it's going to be a linchpin type scenario.
Yeah. I guess three things. One is the first two were sort of identified back in the very first FAA UAS roadmap. I think that was around 2012 or something like that. And those two technologies are areas we play in now, which is command and control and detect and avoid, right? Those are still sort of the two technical challenges that the industry needs to get through to sort of unlock broader BVLOS operations. Command and control from a frequency and performance perspective, the detect and avoid primarily from a non-cooperative detection perspective. By non-cooperative, I mean aircraft that don't have ADS-B on board and telling you where they are. So there's still a lot of single engine piston aircraft out there that are flying without ADS-B, and unless you've got some technology on board to detect them. The problem is those technologies to detect the non-cooperatives are A, too big, B, too expensive, and C, don't work as well as we think they might, in order to close the business case of how that works. And so you're seeing a lot of companies, even like ourselves, go back to ground-based systems because the airborne systems aren't there yet, right? So, installing radars or systems like the Iris automation Cassia camera system, right? Or, Fordham and Echodyne were sort of pioneers in small form factor radars. they started off focusing on airborne systems, and then they decided they needed to pivot and go to ground-based systems because turns out it's hard and physics kind of gets in the way, right? And so that's not, I don't see that getting solved. The non-cooperative piece, it's not getting solved for smaller aircraft. It's getting solved for larger aircraft that can afford the weight and cost penalty, but that's not getting solved. And then the third problem is, talked about a bit more on the defense side, but it's just as important in the civil side, which is what happens when we lose GPS, because GPS is sort of the critical underlying technology for how we know where that aircraft is and where it's going next. And, it could be a disaster if something happened, widespread GPS outage occurs when hundreds of aircraft are in the air. And so how do we mitigate that particular concern?
Well, it's funny you mentioned return to ground base. In the UAS arena, just as a small operator, we tend to operate in places where they're in close proximity to general aviation training.
Mm-hmm.
And one of the places we would fly was an unimproved airfield, because traffic there is fairly low, except when the students want to come in and do low-level passes.
Yeah.
And so, the interesting thing is when we first started doing it, we would put out radio calls. We would get on frequency, and every 15 minutes, we would state the name of the operational area we were in. We would say drone operations 400 feet and below, just to let folks know, hey, we're here, and this is our location. Well, and then we got guidance that no, that's a non-desirable. Stay off the frequencies. that's no go. And the funny thing is, all our folks they're man-rated pilots.
Sure.
They were using common sense, best decision making, but the guidance that came out of the top was don't do it. So we started thinking, this is one of those scenarios where you could have helo ops, rotary wing, you could have general aviation training that they may not be looking for UAS, yet those are probably two of the most vulnerable crossovers, I'll say, possible intersection points. And it really does beg the question that if we start having complex UAS operations in locations, it'd be beneficial if we had a way to record, monitor, and we can do that. We can, if they're ADS-B compliant, we can listen and know, hey, at least they're there, so that when they come into our operational area, we can come down and land. Yep. But it would be beneficial to be able to capture the non-compliance, the folks out there that just, they're in maybe experimentals or other aircraft that aren't going to be carrying that technology, or they're waivered, whatever. Some in the past we've talked about maybe optical systems, so that it could also, we have a problem with birds. Some of the larger turkey vultures in our area like to get territorial, and they'll come in and sniff a fixed wing. They don't come near the rotary because the sound, I think, sets them off, but they like the fixed wing. They'll come in, take a look at it, and sometimes take a slash at it. And, one of our birds that actually has a feature that we just hit a button and it'll barrel roll, or it'll drop a predetermined amount. So, but getting back to it, it would be beneficial for us to have some kind of mechanism as operators to just drop a tripod, set a system, and let it alert us, hey, there's something coming into your operational environment. You need to consider landing, or at least be aware of this, so you're on the lookout of it, so you can intentionally deconflict your stuff.
Yeah, and one of the opportunities that we think we see, we'll see if it pans out, because not all of them do, but why should every single operator have to invest in that system? if you've got that system set up in a widespread area and operators want to come in and, plug into it, either literally or figuratively, right, to gain access to the data that system is feeding you, right, then perhaps you pay a monthly subscription fee to get access to that versus, several hundred or thousand, not hundreds of thousands, but, several hundred or a few $1,000s in particular equipment for your individual operation. And every one of you out there has to go invest to that same amount, right? There's just a scaling of that could possibly make sense, especially if someone can come in and qualify that system for from an FAA or safety case perspective, that we know the performance of that system in that given area that you are operating in, and here's your operating limitations for that area if you're using that system. So that's kind of a direction I think we're heading.
Imagine if that type of capability was interoperable with before you fly, so that
that's right,
you could see it real time to know, okay, things are too heavy here, I don't need to take off and fly here.
Yeah,
and start to get a good picture, make it truly interactive. But
yep.
I look forward to those days. Well, on that, I want to open up the session to the class. If you have any questions, any comments, any aspects you'd like to maybe start delving into a discussion about, now's a perfect time. Go ahead and raise your hand. I will most likely start to taper us down as we approach probably 7:50. I'd like to see if we can wrap up before 8, but I'll stick on, and I'm happy to talk to you all afterwards if you have any questions for me. But now I'd like to open up your questions for Christian. I think we do have something in chat, so I'll read. Yeah, Thomas asks, to support drone operations, there's a low-cost system that can be set up to monitor nearby aircraft that have implemented ADS-B. Outstanding. And yeah, that's your product.
Yep, one of ours. Yep, that's one of ours. Yeah, we have a number of that's what we categorize as a portable ADS-B receiver, right? And so that's that one is the smallest. It's about the size of a pack of gum, like the old school pack of gum, not even the deuce packs of gum, right? And it's just powered by USB plug. But yeah, that's great.
So Amanda asks, and this is something I can tackle real quick. Are there plans for a UAS air traffic control system? And that's actually called the UAS traffic management, UTM. And there is a whole field all focused on that concept and building it and making it a reality. I'll make sure I share some information on where we're at with UTM if you want to talk about your guys' effort in that.
Well, the problem with UTMs is that they've sort of built up their own hype over time that they're going to solve world hunger, and they're going to be completely AI driven and intelligent and deconflict everything. What we don't want to do is wait for that utopia to come forward before we can conduct operations safely. So everything sort of we focus on is operate, sort of implementations independent of this future state UTM. Current state, they sort of deconflict flight plans. That's how I'd describe it. So I plan to fly from in this particular area at 3 p.m. tomorrow, and if someone else plans to fly in that particular area or overlapping area at 3 p.m. tomorrow, it'll let you know, right? It doesn't prohibit you from doing anything, but it'll let you know that you've got some potential conflict there. So they're still pretty young in the state of capabilities that they are operating.
Amanda did have a follow-up that I just want to quickly address, and then we'll go to Eric and then Thomas. She asked if this would be controlled at the federal or state level. I'm going to jump in and say this is one of those things that falls under aviation preemption. I highly doubt you'll ever see control at the state level or local level. It's going to be federally mandated and monitored the same way modern air traffic control, including next gen, is managed. That being said, you may have some specialized operations like that occur maybe for air shows or other regional events that have a coordinator that may help to establish operations locally, but ultimately it's all under the federal umbrella. So, Eric has a question. Is UAvionix active in ASTM F38, the UAS standards committee?
We are members of F38. We are not incredibly active. When there's a particular topic that we're interested in, we'll hop in and provide some guidance or not. One area that we are somewhat active in right now is the finalization of the remote ID standard that's being done under ASTM F38. We have leveraged some of their standards previously in the to inform the guidance of the development of our products, so they've got some standards, like how to build a good C2 radio or things like that. But we're not as involved in that one as we are with our TCA.
Excellent. I'm gonna go ahead and invite Thomas to go ahead and ask your question.
Hello. Yes, I just wanted to mention the ping USB. I use that all the time at the field that I fly in, because we have helicopters and Marine Corps aircraft kind of flying over there. So I saw that product, and it's a nice, just a nice little notebook. And that product, I can actually watch what's flying around me. So
Great.
Do have kind of a follow-up to the F-38. Now that the remote ID method of compliance has been published, is that something that your company is going to go into as far as remote ID products?
Yes and maybe. We have. I'm not sure if you're aware of. The FAA has a series of R&D awards every year called Broad Agency Announcement Awards, right? And so you put forward they're very broad in concept. They give you some topics that they would like to see explored, and then they'll fund you for some development and demonstration of capabilities. Last year we put one in regarding remote ID, and in particular, not just remote ID from a module perspective, but how you could work with remote ID to bring it into something like the ping USB. So a ping USB portable receiver that would be able to display remote ID traffic alongside the ADSB traffic, as well as networking remote ID receivers on the ground, so that you would have sort of a persistent surveillance of critical infrastructure, for example, for remote ID. So I think we're 2 months into a 12-month project now on that one, and so we're working on that. We have a couple of concerns about remote ID in general. We don't think it's going to work very well, frankly, right? From a performance standpoint and frequency and power level standpoint. And so that's one concern that will yet to be seen. From a business perspective, the bar is pretty low in terms of being able to develop this technology, because it's based off everyday Bluetooth and Wi-Fi frequencies and chips that you can buy for a couple bucks, and so you're gonna see initial prices be fairly expensive, but you're gonna see lots of entrants into the market that's gonna drive it really down to something really inexpensive, which, to be honest, was FAA's intent. They wanted something really inexpensive for this purpose, but from a business perspective, it's not the greatest attraction. But it's required, and we have an autopilot, and so we're going to need to integrate it into our autopilot solution. We may integrate it into some of the other products that we have as sort of features that make it, make our products a little more competitive as compared to, another product or something. So I think we'll be there. Not everyone internally is happy about it because we just don't think it's the greatest of designs and solutions.
I have a second question. With respect to your beyond visual line of sight C2 network, has there been consideration of 5G, and is 5G reliable enough to support that kind of a network or operation?
I use LTE 5G sort of ubiquitously, right? And so we are using, yes, LTE 5G modems in some of our radios. So the ability to mesh those together with sort of traditional RF terrestrial radios is part of our overall design. So as 5G becomes even more broadly used, it'll just sort of be inherited by our designs.
Okay, thank you very much.
Yeah.
So Obed asks, have you considered exporting some of your product concepts into countries outside the US that are also working to integrate drones into their airspace, countries such as Africa? And if yes, what are some of the challenges?
Yeah, actually, we took a look at our product mix and our financials not too long ago, and we're about 50-50 shipping into the US and outside of the US right now for our drone products capabilities. So we're pretty well suited there now. I would say that mostly we've been focused in Europe versus Africa or other countries where I agree there seems to be a greater opportunity for leapfrogging of technologies of unmanned systems in Africa, for example. But just frankly, as a small company, it's logistically very hard for us to do that.
Eric asks, what are your thoughts on how remote ID should be developed? I agree that our ID is very nebulous.
Well, I was a part of the what's called the Aviation Rulemaking Committee, ARC, for that, and you guys probably have talked in your class about the recent ARC out for the BVLOS stuff, but there was an ARC for remote ID several years back, and we looked at every conceivable solution that ranged from ADS-B to something like ADS-B, but on a different frequency, to cellular technologies, flashing lights, literally, flashing lights that could be interpreted like Morse code, right? Something like that, right? I mean, it was a broad spectrum of options. I was on the proponent of ADS-B at the time, but I probably mischaracterized it. What seemed to be important to me, and still was the ability to use remote ID as a detect and avoid system in addition to what its intent is. It's important to know that its intent is not detect and avoid, its intent is security. The entire use case was, how does a law enforcement official identify who is flying that drone that I see, and how can I go talk to the person who's flying it? It had ultimately had nothing to do with detect and avoid. And I felt that was an amazing waste of an effort and a standard and a frequency. If you're going to go through all of that trouble, give it dual purpose or multi-purpose versus that security purpose. So that's how they ended up with Wi-Fi Bluetooth beacons, because one of the requirements became it has to be received without any special equipment other than your phone, right? And your phone can only pretty much receive Wi-Fi and Bluetooth, and that's how it settled there. And I felt like it was a huge waste. Now, what's happened since then is, okay, we've settled on Bluetooth and Wi-Fi, and we've taken away ADS-B. So what do we do? How do we detect and avoid cooperatively here without those two options? And thankfully, it's coming back around as a known topic, and you'll hear it described as a vehicle-to-vehicle frequency, the V2V. And I was in an FAA roundtable event 2 days ago on Monday. Was it Wednesday? Yeah, on Monday, where industry and FAA were together brainstorming what this vehicle-to-vehicle system should look like from a use case perspective in order to eventually drive a standard that would be developed for that. Now, to their credit, they have recognized that this system should be operated on licensed frequencies and not open frequencies. And so, which was my biggest pet peeve during the ARC process in general, was that the open frequency would never get you to something like detect and avoid. But it sounds like it's coming back around. Just knowing how the process goes, we're years away from a vehicle-to-vehicle standard and implementation, but at least I feel like we're moving in the right direction now.
Excellent. Well, is there any other questions? Has everybody kind of got a better understanding of where we're at with? Oh, we do have one more comment from Richard. Thank you, Christian, for sharing your knowledge. Do you think it would be feasible in an urban environment with 4G/5G coverage only to use the hardware already included in standard flight controllers in combination with telemetry to deal with remote ID, detect and avoid, and ADS-B in and out functionality entirely from the GCS or ground control station environment?
There's a lot packed into that question.
Yeah, there is.
So what was interesting and why we exist is you can go buy a chip pretty cheaply, and I'm talking about a few bucks, that will operate on Bluetooth frequencies and Wi-Fi frequencies 2.4 and 5 gigahertz. And you can go buy a chip that is a cellular modem for a handful of dollars as well, right? And the mobile phone industry, we literally have to thank the mobile phone industry for drones, because the MEMS sensors here are really what drives the autopilot flight controller solutions. And they weren't invented for drones, they were invented for phones. And those chips were invented for phones that operate on those frequencies. So you can do everything that I think that you described there, except ADS-B, because there isn't a chip you can go buy for a few dollars that operates on 1090 megahertz, because it's a protected frequency from an aviation perspective and from an FCC perspective. And they're just, they're in the thousands of units per year versus the millions of units per year that these silicon companies invest in developing. So our whole premise was, if we can invest in a chip that would bring the cost down of ADS-B, banking on the high volumes that we would see out of drones, that investment would be worth it. Now, our plan didn't quite work out that way, so which is why we've tried to, leverage that chip in every direction that we could, and why we're in airports and general aviation and defense now, because we invested in that, and now we're doing everything we can to do that. But I think that everything you described in that question is possible, except for the ADS-B component.
And then could ADS-B be a software solution?
could ADS-B be a software solution? I mean, ADS-B is kind of by definition an RF technology that, you know, operates on a specific frequency with a specific protocol. So in that sense, no. The idea behind ADS-B, which is you're getting aircraft locations from the aircraft themselves and bringing that into you know, a common picture of the airspace. Absolutely, yeah, you can get that right from the ground control stations that plugs into the network, right? And you could get all of that, you know, from that perspective. Yeah.
So we have one last question, and after this, we'll cut off the questions. And if anybody wants to stick on and chat with me, I'm happy to. But I want to just make sure we move along for Christian's time. So Connor, if you want to ask your question.
Yeah, absolutely. So kind of circling back to the C2 network, as well as costs. I know you discussed with like detect and avoid and building this ground infrastructure would be very expensive for every single operator. So you're obviously minimizing some of that cost by building the infrastructure, but how are you minimizing that cost for yourself? So are you using existing infrastructure? And then I know you said the 2 implementations that you have right now are test sites, and then you're possibly having one. Is the new one going to be like a single operator? So how does that business model work and scale to the point that it actually becomes profitable?
Yeah, there's a couple of different models occurring right now. The one in North Dakota is actually it's not a test site driven effort, even though the test site is sort of the umbrella organization that are implementing it, but it's the State Department of Transportation investing in a network that they believe will bring commercial operations to the state. So it's the same concept as investing in a road network that can handle, you know, tractor trailer commerce, right? It's building the infrastructure that will allow commerce to come into my state. And so the Department of Transportation itself, it's a state-funded initiative to build out this statewide network that they hope will bring business to the state. So there's an initial funded element of developing and installing the equipment, that's capital. And then ultimately there will be an operational cost, but the funding of the development is paid for by the state. So that's one model. Another model is, what if we did it ourselves, right? Our costs obviously aren't the same cost that we would pass along to a customer, right? We've got margin and we've got markup, but our costs are less, and we could invest in deploying a network ourselves and offering those services to a region. Now, I think we will do that. I don't think the industry is quite ready for that yet, but we're, you know, keeping our you know, fingers on the pulse of things, and when we think the industry is ready for that, we will. Another model that's kind of interesting is a large scale operator, like a utility company, who already has invested heavily in, I'm going to give some hints here if you picked up on it, right? But you've got a state right now that is recovering from a disaster, and part of that disaster is power outages. And you know that the utility companies are out there, because I heard at the beginning of the call, inspecting their infrastructure to determine the extent of the damage. They're already doing this, and they want to take that capability to the next level. So they want to invest in infrastructure that allows them to take that capability to the next level by building out networked capabilities to do that. But once they do that, they can offer those services in that network that they invested in for themselves to other operators in the area, maybe Embry-Riddle.
Are you working with Eric Schwartz?
Shh.
He was one of our former UNSY SME guests. So he talked about yeah, some of the things that they're doing. So
Yeah. So
outstanding.
we're working pretty closely with Eric, and I hope to be moving into Florida soon. So let's see. Yeah.
Well, we wish you a warm landing and a dry landing.
Yeah.
Well, outstanding. I just want to thank everybody for joining tonight, as well as a huge thank you to Christian for sharing his perspective, his thoughts, and most importantly, his time. This has been a very informative and enlightening session, and I hope it helped to bring you a better understanding of the future of this field. Remember to receive credit for your participation this week. You're going to need to just develop a real brief overview for Module 9 discussion. Identifying that you were in attendance and describing the knowledge that you gained from tonight's discussion. So with that, thank you again, Christian. It was great catching up and seeing you, and I really appreciate you coming into the class. And for everybody else, I'm going to stick around if you got a couple minutes, you want to just chat. This is our last week of the term. Happy to go over things.
Thanks, everybody. Great questions. And hopefully we'll see you guys soon. I think I recognize some of your names, so it's great to see some folks in the industry in this.
Thank you, Kristen. And I saw several of your people up here at Summit UAS. So
Good. Well, I hope to be talking to you soon.
yes, definitely.
All right, guys. Thank you.